Hello everyone and welcome back to Arctic Retro. So this is part 1 of my series, so now where I'm gonna build a Commodore 1581 floppy disk drive. So finally I'm there. I got most of the things I need to start building it, and hopefully this will be an interesting project for me. And of course I also hope it will be an interesting project for you. So I know there's been several videos out there from other YouTubers that have built the Commodore 1581 replicas, but this is gonna be my take on that. I haven't really seen a lot of those, so not really sure what to expect of problems and things like that. But we'll see how it goes. By the way, when it comes to my Commodore 128D machine build, I went into some trouble and I couldn't repair the motherboard, so I sent it off to Coiro, my friend, and yeah, good news, he actually repaired the motherboard and he's sending it back to me now. So after this series I'm gonna be able to continue that series as well, so I'm gonna complete that build. Alright, I think this is gonna be a lot of work, both for the build itself and for testing and yeah, perhaps some troubleshooting. We don't know, we'll see about that. For the purpose of these videos I have found my golden Commodore 64, which is a machine I built myself. I painted it myself. You can take a look at the videos. It's built from a replica motherboard, so yeah, what's better than to build a replica motherboard 1581 floppy disk drive. This video is sponsored by PCBWay, and I just want to say thanks to them for supporting my channel. As a hobbyist, I often find myself in the need of some PCBs for various projects. And of course, PCBWay is my favorite PCB manufacturer. Not only do they provide prototypes PCBs for reasonable prices and with quite amazing shipping times, they can also provide you with other hobbyist needs like advanced PCBs, PCB assembly, SMD stencil, CNC machining and 3D printing, and various other products and capabilities. And for those of you who doesn't know what this drive is, here's a couple of pictures of it. It is in fact a 3.5-inch floppy disk drive, and it came to the Commodore machines quite late in their lifetimes. Those of you who had Amigas back in the day probably know this format a lot better, but for the Commodore 64 and the 128s this was not that common. And yeah, actually if you find one of these originals used for sale, they can go for as much as $1,000 US or even more. So I actually never considered even to buy one, because that's way too much for me. Not that I can't afford it, but I think it's too much to pay for such a special thing, and I'm not that hardcore collector either, so I don't need to have something. If I want something, it's because I want to check it out and use it a little bit, not for storing on a shelf. I'm not gonna dive too much into the details about the specifications for this drive. You can easily read that on Wikipedia. Here's the Wikipedia article. And here it says it was released in 1987, and it then cost around $400 US, and it was discontinued in 1990. And it uses 3.5-inch floppy disk, double-sided, double-density floppies using MFM format. It has a built-in 6502 CPU and a WD-1770 floppy disk controller produced by Western Digital. And the floppy can store 790 kilobytes. And here we have a little collection of old floppy disk drive from Commodore. So the closest thing to the 1581 when it comes to the design and looks of it might be this one. This is a 1541 Model 2. However, this is a 5.25-inch floppy disk drive, and it's compatible with the original 1540 and 1541s back in the day. So there isn't much thing special about this one. What I got here is actually a replica or a clone of a 1541, still 5.25-inch, and yeah, this one actually works rather nicely. I have tested it and it worked very nicely. And here's in fact a 1540 floppy disk drive. And this one was the predecessor to the 1541. This one came with the WIC 20, if I remember correctly. And yeah, while it is compatible with the 1541, or let's say the 1541 is compatible with this one, it has a few limitations. But you can upgrade this with replacing the ROM, and then you can use it as usual on a Commodore 64. Anyway, this was about the 1581, so let's take a look at the board I'm gonna use when building it. Yes, and as you can probably tell by now, this PCB I'm gonna use was produced by PCBWay. That's my sponsor, and I just want to thank them a lot. They provided me not only one but 5. You can find them at PCBWay shared projects, where you can just simply click at the board and then you select the colors and some other parameters like what kind of metal finish you want, and then you just put it in the shopping basket and pay for it, and they will produce 5 copies for you in a matter of a couple of days, and then have them shipped to your door in a matter of a few days after that. And these boards I selected matte black. Probably gonna make some fingerprints on that, but yeah, as you can see, it doesn't actually do that if I really try, but I think they look just amazing. I already gave away one, so I have only 4, but in this video I'm just gonna build me one. So I'm gonna select the finest one. Well, they're all just as fine, so yeah, I think I just randomly pick this one then. I don't think this soldering job is going to be particularly difficult. If you have some experience and building motherboards like this, it shouldn't be very difficult. You have a couple of chips here and there, some smaller components like resistors and capacitors and stuff like that. Then you obviously have the connectors on this side. One thing you need to figure out before you start building this is if you're going to use the built-in power connector, which is the same as on the original 1581. If you're going to go with that, then you will probably need an original power supply for the floppy disk drive, and that can be a little bit hard to find nowadays. Or you have to buy a modern replacement of that, which can be expensive. Or you can select if you want to have the alternate power, which is a regular 12-volt input that gets regulated here. And yeah, you connect it to this connector here, and then you can do whatever you like. If you want to have a barrel connector here on the back side somewhere, or if you want to just do something else, like if you want to feed a cable out or something and just hook it up to your own simpler power supply. Or you can do both. You can have both the original connector and the alternative. And you can select which you want to use using a jumper. And yeah, of course that jumper can be fed out using a switch where you can switch between. I think I will at least solder in the original connector, but during the video I'm gonna figure out if I'm gonna use the alternate power and if I'm gonna mount a separate power input contact for that. We'll see about that later. Then of course it's not enough just to solder the board and get all the components right. You also need the actual physical floppy disk drive, and yeah, there's a couple of choices there as well. You can use an Amiga drive like this, and I think this can be used directly without doing anything else. You just hook it up, the power and the data cable, and yeah, not really sure what type of drive that fits best, if you need to remove the casing and stuff like that. Or you can use a PC floppy drive, but then you need an adapter because this board isn't directly compatible with the PC drive, so that's why you need an adapter, and I'll come back to that later as well. But here's one of those adapters, and I will check out this as well, even if I'm maybe not gonna use it, because the third option, I actually ordered a floppy disk drive for this purpose, and that is a PC floppy drive that has been modified on the floppy drive instead of using a adapter like this. So I'm getting a working modified floppy disk drive that is specifically made for be used by the 1581 replica. Finally, after building this, of course we need a case, and we need it to look nice and need to look as the original. So this is a Commodore 1581 replica case from thingiverse.com, which is a place where you can find free 3D models, and yeah, here's everything you need for printing this yourself. And that's one thing I'm gonna do. However, this is kind of a large 3D project consisting of several files, and yeah, you have the upper and lower part and the front, and you have some bezel inside, and you have the button. This is going to take many hours on my 3D printer. And there's also the matter of the color. I know you can find 3D print filament that matches the original color quite nicely. However, I'm going to use a light grayish or a gray-white type of color. I think it looks quite close to the original, but we'll see what it turns out to be. But also in this video I'm going to check out the PCBWay, because they have a 3D printing service. If you visit PCBWay.com and go to 3D printing, you can just upload your CAD files. They support many different types of files. The ones that we usually use with 3D printers are STL files, so you just select one or more files and just drag them right into here, and I already did that. But they haven't started yet on the production, so I'm really looking forward to that. It says here build time 8 to 10 days. That's because they have some Chinese holiday right now, so it's going to take a couple of days longer. So I just uploaded all the different parts, and there's also a couple of different variants of the front. So in total 9 different 3D models, and every single model isn't that expensive to print, but if you have 9 different models as I have here, then it is getting a bit expensive. So luckily for me, PCBWay, they have sponsored this project, so they're gonna print all these models and send it to me for free. So again, thanks a lot PCBWay for that. So that's going to be interesting to see if the professionally made 3D prints are any better than my homemade. Hopefully they are. Okay, I think you are not here to just listen to me talking all the time. Let's start with some action, and the first thing I'm going to do is to find all the parts for the PCB and then start soldering. I'm going to start with the smallest components and the sockets, and after that I'm going to do the connectors and stuff, and we'll take it from there. So obviously there's some work involved. I estimate soldering up all this gonna take a couple of hours, so I'm obviously not gonna show the whole process. Just gonna show you some bits here and there, and if anything particularly interesting or bad happens, then I'm gonna record that. First, I need to find all the components, and I got most of the, like, let's say the new components from DigiKey and Mouser. So let's see if we can organize all that. I got some parts from Mouser because that was parts I couldn't find at DigiKey. Besides that, I usually prefer DigiKey. And as usual, whenever I order from those large vendors, I usually get more than I need, because if you get over a certain amount, the shipping is free. So by adding up and stocking up on some of the components, yeah, it's becoming much more cheap if you don't have to pay shipping. Okay, so here's a couple of things. These are ferrite beads. These are the SRAM memory chips. I got 2 of those, even though I only need 1. And this is some brand new 6502 microprocessor. This floppy drive uses the 6502 microprocessor, which is the same as you find in many other 8-bit retro machines, including the VIC-20. However, these are newly made, but they are compatible. But these can run a lot faster, and they run less warm, and this is the W65C02. You can run into issues by using these modern variants on old machines. However, these are supposed to be working with this board, so I'm gonna try that out. If I get into trouble, I have some of the old variants I can use if I want to. This is the same power switch that you have in the Commodore 64 and probably other machines as well. So if you don't find such a switch and you need one, then you probably can find a used one from an old Commodore 64 scrap motherboard or something like that. Then I have all these components from DigiKey, and yeah, there's all sorts. There's resistors and chips, all the logic chips, capacitors, yeah, everything else that you need except the rather specialized contacts. Sockets, I wanted good quality sockets. I didn't want to use the cheap ones I have bought from China on eBay. Let's just start soldering. Start with the smallest one first. And as for preparation, I have even cleaned and pre-tinned my smallest solder iron tip. So now that's ready. So we're gonna go from this, but I need something to look at. What is it gonna look like when I finished? So I'm gonna go from this to this. Put it there. Let's see. Now I think I need some more details to be able to build this. So this is the bill of materials list. So I wonder why these ferrite beads are always packed in a lot of plastic and it says fragile. I have bought the ferrite beads before and they always comes packed like this. Do they break easily? I'm not really sure. Okay, yeah, maybe they break easily, I'm not sure. First of all, I'm gonna clean the back side, the solder side of the PCB a little bit. Might be some dirt or leftover fats from the production. although I doubt it. It looked very clean, but still good idea to clean it off. To make it a little bit easier, I'm going to use this soldering rack here. That makes it easier to solder, and you can turn it around like this, so yeah, this helps. Yeah, that's perfect. Okay, so according to the bill of materials, we are going to start with the ceramic capacitors and some electrolyte polarized capacitors. Just going to follow this list, even though it might not be the most correct order, and I will cross off as I go. So there's 14 100 nanofarad capacitors. Let's find those. It says here cap SER 0.1 microfarad 50 volts. Yeah, that's the same as 100 nano. And where do they go? I guess they go all over the place. C1 to C14. Yeah, there's some here. C14, C15, C2, 3. Yeah. C8, C7. Yeah, these kind of ceramic caps, they're not polarized, so it doesn't matter what direction you place them in. Okay, so placing and soldering several components at the same time, it saves a little bit of time. So now I'm just going to turn this, and to prevent those from falling out again, I have bent the pins on the backside. You can of course do something else if you like, if you want to have some tape or something to hold them in place. And there's one I didn't bend. Then basically a little bit of solder, and we're in the game. Yeah, it was very easy to solder on this brand new PCB. That's good. I have a very nice solder tin here, leaded with flux inside, and it's very thin also, so it's very easy to solder. Yeah, that was all those caps, and now I have messed up the board with lots of flux residue. However, I'm gonna leave that until the finish, because then I'm gonna clean it really good. So a little bit of snipping action, and yeah, over to the next one. I prefer not to take too many components at the same time, because then it just becomes a mess and it's hard to get your solder iron tip in between all the different legs. So then I just go over all the solder joints and see that everything looks alright, and if something looks a little bit crooked or not alright, then I just go another pass. Yeah, most of these look alright, and you can also check if they're not bent or anything. Some of these have place them a little bit on the side like this. Just gonna quickly fix that. Ideally you should see that the solder comes out a little bit on the other side, like here. Maybe that one got a little bit too much, but yeah, that's not a big deal. So I ordered a lot more components that I actually needed, so yeah, now I have some spares. Next one is just a single 10 nanofarad capacitor. Just gonna solder in that, and then we have some electrolytes. So yeah, just gonna continue with those, then I'll be back. Yeah, that was the electrolytes, and yeah, those are important to get the correct polarity on, and as you can see there's a marking on the PCB, plus and minus. However, I think I made a little mistake here. I should have gotten some other type. I mean, the values are correct, but I should have gotten a little bit lower profile capacitors that would stand flush with the PCB and not standing up like this. We'll see how it goes. If that becomes an issue, then I might replace them or bend them down like that if they're gonna get in the way of something. We'll see. Just have them bent down like that for now. But you see those kind of details, it's not written in the bill of materials at least. So next is some pin header connectors and some DIN connectors, diode, some ferrite beads and filters. The DIN connectors I'm gonna wait, I haven't received them yet. So here's a diode and it's the CR4 and this is a small 4148 signal diode. These are particularly important. You get the right polarity and you can see there's a little mark at the end of the component and that should correspond with the black band on the component. Then we have some nice looking blue EMI filters. Next up we have these ferrite beads and I actually had a hard time finding them. I think these are the ones that are listed on Mouser, but I couldn't find any on DigiKey. However, these are a little bit big. I need to bend them a little bit to make them fit. I'm not really sure if it's the exact same type, but yeah, I think they will work anyway. So I just bent one of the legs and the leg is very thick, so it just fits through the hole. Yeah, I think that will work, but I think these beads are a little bit bigger than what was their originals. I have started with the pin headers. I soldered in connector 1 here. Ideally it should be one of those locking type of contacts, not a regular pin header like this. The floppy drive connector, it consists of 2 rows of 17 pins of pin headers, and to make sure they're straight you can just use just a floppy disk connector and connect it in first before you solder, and then it should be perfectly straight. So I went a little bit further now. I have installed all the individual resistors and a couple of the resistor networks, and these are 7 resistors of the same value that are connected into a common ground. And yeah, on these there's a little dot on one side which goes to the square hole on the board like this. It's important to get it in the correct direction, obviously. So if you have experience by building electronics like this, you probably think I am over-explaining stuff. But I still think there's probably a lot of viewers that don't have any experience with electronics, and they might want to start doing some stuff themselves. So because of that, I try to inform about even simple stuff like this. Be a little teacher here. So next up is the dip switch for the device selector. Unfortunately, I was not able to find the correct type of switch. I got this one, but as you can see, the switches point upwards, but ideally they should point that way. So the BOM actually described an angled dip switch. However, it was not available on Mouser or DigiKey, so I just went with this. That was all the smaller components. Yeah, what's remaining now is the chips and the big contacts, which I'm gonna wait with. Yeah, I'm not gonna solder chips directly to the PCB, obviously. I'm gonna install sockets, and I got brand new good quality sockets from DigiKey for this board. Ready to install some sockets, and just need to make sure that they are all in the correct orientation, which I already found one that was not. Obviously the notch on the socket, which you can see right there, it's supposed to be where the marking is on the PCB. I'm gonna solder all the sockets in one go. I'm just gonna use a little tape here to hold them down. Then we have a lot of soldering. So in order to get the sockets right flush down to the board, I am just soldering two corners first. And then I just, from the back side, I just push the socket a little bit, and yeah. It then just aligns itself right flush with the board. Yeah, that came a couple of millimeters, in fact, yes. Okay, let's solder a couple of hundred solder points here. Oh boy, that was all the sockets, a lot of boring soldering. Well, sometimes it's kind of relaxing to sit back and just solder. So now I'm just gonna clean up this mess. I'm gonna double check and triple check all the solder joints here, see that I have soldered everything and that I don't have any bridges or anything like that. To remove all the flux, I just spray a little alcohol on. IPA, we call it isopropanol here in Norway. It's called isopropyl alcohol, I think, in English. Okay, so to completely wash this, I am gonna take it down in the sink and wash it with some real dishwasher soap. I have cleaned up the board and it looks absolutely fantastic. Yeah, cleaned up really nice. Actually, what's remaining now on this board is just the contacts, and besides that I need to populate the chips, but I'm gonna wait with the chips until this board is completely finished. Yeah, just wanna have it sitting flush right down to the board. So these are some really big holes and thick pins, so might need a little bit additional heat. Now that seems to be working. I just solder in one of the pins, and then I just press down onto the switch so that it's really flush to the board. Oops. Then I pause a little bit because I'm afraid that there's going to be too much heat on the switch itself, so I just wait a little bit for it to cool down between soldering each of the pins. I mean, since it's a plastic parts involved, it can melt. Okay, that's in then. Hopefully it works. Just one more thing I want to do. If you remember, I said that you could use an alternate power supply. It's this jumper here. I already soldered it in, but in order to use that, you actually need a couple of more components. You need a voltage regulator and a capacitor there, so I am gonna install that as well. And there's also one capacitor that goes there. It's a small 4.7 microfarad, 50 volts. Voltage regulator goes here. It has a hole here, so I probably should have a heatsink. I don't think I have one right now. And then we have the big capacitor here, and here I think I have a little issue because it's supposed to be a 1000 microfarad, 16 volts. I only have this big one there. Besides that, I have some of these radial ones. I think maybe I'm gonna try and fit this in instead. We need to improvise a little bit. I'm not gonna order just one capacitor for this particular purpose. Yeah, so that's how I bent it. It's gonna fit right into there, and that's how it's gonna be for now. I might replace it later with a proper axial capacitor. Yeah, that's not gonna go anywhere. I mean, it's a little bit wobbly, but I'm not gonna transport this drive around. For the 7805 voltage regulator, I need to fit it to the hole. You just need to eyeball it there, I guess. Bend it something like there. Yeah. Afterwards, I just need to find a screw to place into that, and I'm actually gonna place a heatsink on top of this instead of having something underneath. Finally, to route the power from the alternate power supply, we need a jumper here. So to use the alternate power supply, you jump between 2 and 3, and to use the built-in power supply, you jump between 1 and 2. So now we can actually test this alternate power supply, see that we get 5 volts out of this. I just place a little heatsink on top of the voltage regulator. Not gonna help a lot, but maybe a little bit, maybe that's enough. I'll see when I start this up and see if this gets very hot. If it does, then I need to figure something else out. Alright, let's test this. Anyway, I'm just gonna use my bench power supply here and just hook up, see if we get the nice 5 volt line out of this. Now with a voltage regulator, you can have a varying voltage input. Let's say you have from 6 to 12 volts DC in, and then you should have a steady 5 volt DC out. So let's try with 7.8 volts here and see. Okay, let's test this then. 7.8 in, and then we should have 7.8, which we have, and then we should have 5 volts out. Yeah, that's 4.98, so that's good then. Okay then, this is how far I'm gonna take it in this video. So there's still a lot of work to do, but still missing a couple of parts that I'm waiting for. So I'm gonna stop here, and in the next episode we're gonna populate the board with some chips and hook up a floppy disk drive and maybe actually see if we can start testing this. And then finally, I'm not sure if that's going to be next episode or if there's going to be a one after that, but then we need to make a case for this drive. Okay, hope you enjoyed this video, and I just want to say thanks a lot for watching, and a special thanks to my patrons. See you, bye bye.